Hi, I'll be giving a quick introduction to myVGL in the next few minutes. myVGL is the free viewer application for projects created with VG software. This includes VG Studio Max, VG Studio, VG Metrology, and VG Inline. We'll be starting with the options to open a project, then to a general overview of the user interface, and finally the most important information about analyses, measurements, and how to extract information out of myVGL. To open a project, you can go to File and click Open. But first, let me show you what a VG project consists of. Usually, you'll find VGL projects. VGL projects consists of a VGL file, a VG project folder, and usually you'll find a VG data folder that includes all of the data files associated to this project. This can include all the volume files, cat files, surface meshes, etc. But sometimes these files can be saved in different locations. You may also find archived projects. Archived projects or VG archive files include all of the information of the project in a single file. And you may also find VG Metrology projects, which is a single myVGL file that includes all of the information to open the project. But note that VG Metrology does not look at gray values, only metrology information. Let's go ahead and open up the project. I will simply grab the VGL file and drop it into the software. A window will pop out with the options to open up the project or only import the datasets. Here, we want to choose Open Project most of the time because this includes all of the analyses, measurements, reports, and visualizations that were performed to the datasets. Then, the software checks what exactly is in the project, and you can choose what to see and how the data should be loaded. This is very useful when you do not have the most powerful computer available, but still want to see the project. Here, you can see the memory needed to open the project and the RAM currently available in your system. If the required memory is highlighted in green, as it is now, you'll be able to open the project. On the other hand, if not enough memory is available, then you can reduce the resolution of the data here. 1, 2, or 3 voxels in each spatial direction are combined to form a voxel. You can directly see how this affects the memory required. It may not be noticeable here, but with large datasets, you can quickly save several gigabytes of required memory. And if you're not interested in the gray value data at all, you can also unload it completely to work only on the surface data. You'll only have this option when an advanced surface determination has been calculated on the data. Please note that regardless of the resolution you choose to load the data, the results of the analyses and measurements remain unchanged. Even if you completely unload the gray value data, for example, the pores found in a porosity analysis are still displayed in the same way as with full resolution. I will now proceed to open the project at full resolution. This is the user interface. On the right side, we have the scene tree with all the objects in the project. You can also find the rendering tool. By default, we get one 3D window and 3 2D windows, which always show a slice position through the data. The easiest way to see where that is located is by holding down the scroll button and panning. You can also scroll your mouse wheel up or down to slice through that window. You can also grab that slice plane on the other windows and drag it to a different location. If you found a position of interest, you can hover your mouse over it, hold down the control key, and scroll in and out to zoom in and out that location. If you found a position of interest and want to see that position in the other windows, you can activate the navigation cursor. First, we select the volume in the scene tree, and then we go up here to activate the navigation cursor. When that is active, you can hold down the Control key and click in the point of interest. That will bring all of the other 2D windows to that location. You can also click here to make this window full screen. And you can click here again to toggle it back as normal. You can click here to focus on the image. And you can double click to focus on the selected object in the scene tree. The rendering tool will show the rendering settings of the selected object. Here we can activate the visibility for the CAD object. When we select the volume object in the rendering tool, we'll be able to see the histogram. This shows all the gray values of the datasets. Typically, we have the darkest voxels on the left and the brightest voxels on the right, and the vertical axis represents the quantity of voxels. Here, we can adjust the opacity curve to improve the brightness and contrast of the data to better visualize the structures. Click and drag existing handles or create your own by clicking the scroll wheel button. Up here in the Window tab, you'll find several window layout presets that can help you visualize your data. If the project includes bookmarks, you can find them down here. Bookmarks store the visualization and rendering settings of the scene and the objects, and can be very beneficial to quickly see and visualize the important insights in the data. If you hover your mouse over it, it will display a description and you'll be able to see a thumbnail image. By double-clicking it, it will apply the bookmark and it will show you the rendering settings for that bookmark. As you can see, it's very beneficial to have bookmarks included in the project. They can be very helpful to quickly point out interesting findings. All the manual search and visualization adjustments can be saved beforehand for you. Let's take a look at this view. Underneath the volume in the scene tree, we can find a coordinate measurement section with all the measurement features. We can simply click on any of these features and it will take us right to that location in the 2D windows and it will highlight it in the 3D window. This can be very beneficial to quickly go through all of the measurements. Here in the scene tree, there is a color associated with the feature. These two measurements in red are out of tolerance. These measurements in green are within tolerance. If you want to learn more about the coordinate measurements, you can double-click this section here in the scene tree to open up the coordinate measurement results dialog window. Here you'll find the Features tab with the list of all of the features that were measured, along with all of their information. You'll also find the Geometry Elements table with the list of all the geometry elements associated with this object. If there are no measurements included in your project, you can easily create your own. Simply select the volume in the scene tree, go up to the Inspect tab, click on the Distance feature, and zoom in, click and drag to add your measurements. Let's move on and take a look at the nominal actual comparison. You can find it down here underneath the volume, and I'm going to turn on this analysis. As you can see now, the surface of the object has color, which is associated to the surface deviation between the object against the CAD model. Here we can see the overlay of the CAD model. And if I zoom in, you can see the surface deviations that were calculated. If you want to learn more about this analysis, you can double-click the analysis here in the scene tree. This will open up the analysis dialog window. The first tab shows the settings, which are currently grayed out because we cannot change them in myVGL. The next tab shows the colors tab, which we can adjust to change the visualization of the results. Here we can also see the deviation histogram. The deviation histogram shows us the distribution of all the surface deviations. Here we can right-click and create intervals to study specific deviation ranges. There are more tabs that will provide more statistical information on the results of this analysis. Let's now take a look at the porosity inclusion analysis. For that, I'm going to turn off the visibility of the CAD object. I will select on the volume object. I will go up here to the visualization tab, and I will render some transparency. And I will select the indications over here of the porosity inclusion analysis. This allows me to take a closer look at the porosities that are inside of the material itself. Here you can see there's a large concentration of pores in this section as well as in this other section, down here and down here. The analysis may include indications. You'll find them underneath the analysis, underneath this volume object in the scene tree. When you click on an indication, it will point you to that location. Here you can see these two annotations. In the other views, whenever you click on this indication, it will take you right to that location as well. If you want to learn more about the porosity inclusion analysis results, you can double-click the analysis here in the scene tree. This will open up the dialog window. The first tab, again, is the settings tab with all the settings of the calculated analysis. The next tab is the tolerancing tab, where you're going to find the tolerances applied to this analysis. In a similar fashion, you'll get a colors tab where you can change the colors of the indications. Here, we can change what the colors are showing. Currently, the colors of the indications show the volume of each individual pore. Here, in this tab, we can change the active column. Instead of looking at the volume, we might want to look at the projected area in a specific direction, or maybe the projected size on a specific axis. And so here, now the colors of each individual indication are reflecting something else, the projected size, for example. You can find all of the calculated information in the indications table. This indications table will include all of the indications that were found in the analysis. And whenever you click on an indication, all the windows will take you right to that location. This table provides a lot of information. All of the information in the software can be exported. You can simply select a table, you can right-click on the table, and you can export as a CSV or copy to the clipboard. You'll have more statistical information here shown in the Statistics tab. Here we're looking at the distribution of volume. We can change this distribution to show something different by changing the active column. So maybe we want to check the size on Z. So now the Statistics tab is showing the distribution of the projected size on Z. You'll get more statistical information here and annotations if there are any. You can create your own analysis annotations. If you find something of interest, you can select the analysis here in the scene tree. You can go up to the Inspect tab, click the annotations. While the annotations are active, you'll be able to hold down the control and click on an indication. This will create an annotation of the indication, and you'll be able to find it here in this table. Annotations can be created for any analysis in the scene tree. As you can see, having bookmarks can be very beneficial to find things of interest and help people visualize all of the insights in their data. Now you have a good overview of what is in the project and how to visualize the results. Maybe you would like to share some of this through a nice looking picture or video. This is easy using the Save Image and Movie up here in the Reporting tab. Here we have the Save Images, and here we have the Save Movie. This will bring up a dialog window where we can select the options on how to create and save the image or movie. You can also create and save reports here within the software. We can see there is a finished report already. I'll come back to that in a moment. First, I want to show you how to create a new report. We go up here in the Reporting tab and we click the Create Report button. Here we can see the list of the scene tree items, and you can select what you want to report. In this case, I will report the porosity inclusion analysis results. I will click the Create button to create the report. The report will open where you can browse through all of the information that is outputted by the porosity inclusion analysis. You can edit the content of this report here simply by going up here and clicking the Edit button. On the left side, you have all of the sections in this report. You can add more sections here if necessary, or remove any sections that you don't want to see. You can save the report here, but now let's take a look at a finished report. I'll double click report 1 to open it up. And this is what a final report could look like. Here we can see the measurement table with a screenshot of all of the measurements from the 3D window. We'll also have 3D content available that we can manipulate in 3D, along with all the statistical information, all of the porosity inclusion results, all of the information. We can edit any table here by clicking on the table, and on the right side, we can edit all the columns, the order, and what is being shown. These automatic images are created using bookmarks and rules and annotations. They will include 3D content that make it really easy to show the indications of interest. These reports can be exported as PDF here or HTML here. For those of you curious to learn more, in the Help ribbon tab, you can find the reference manual and step-by-step tutorials. Thank you for spending the time to watch this video. If you have any questions about any part of this video or are interested in learning what else VG Software has to offer, please do not hesitate to contact us. Thank you.